Welcome 6th graders to your video lesson on least common multiple, abbreviation LCM. Your learning target is that I can find the least common multiple of 2 or more numbers. So make sure if you're using the template, you stop and think, what do I already know? Same thing. If you're writing in your notebook, make sure you write down the title and learning target, and then let's stop and think about what we already know. Build that confidence, stop and think, what do I already know? So before we begin, we have some vocabulary. Multiple. Okay, so least common multiple. We've previously done greatest common factor. So a multiple is the product of a number and any whole number. So for example, the multiples of 4, we have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. If I were to list those out, listing my multiples, I have 4, and I'm counting by 4. 4, 8, 12, 16, 20, 24, and so on. Multiples are infinite, okay? We are going to go on forever and ever. These are the numbers that we count by. So I think of my multiples as my count by numbers. If I were to ask you to count by 4, that's what you would do. If I were to ask you to count by tens, you'd say 10, 20, 30, 40, 50, and so on. Those are your multiples. This is not to be confused with factors. Remember, factors are your numbers that make a product. So if you're thinking of 10, the factors of 10 are 1, 2, 5, and 10. So factors are the number and numbers less than it. Whereas multiples, you'll notice, is the number and numbers greater than. So the least common multiple of 2 numbers is the least of their common multiples, excluding 0. So we're not counting 0. So what you'll notice maybe right now, even if I did the listing method, 4 and 10, I listed those out. The multiple of 4 was 20, and that was ultimate multiple of 10. So that would be 4 and 10, their least common multiple was 20. So here are 3 methods that we are going to go over to figure out how to find the least common multiple. You might have to change this if you have the template. It should say least common multiple. Yours might say greatest common factor. That was a typo. So looking at them, they look very similar to what we did for greatest common factor. There are some differences, so make sure you don't check out here and say, oh, I got this, because obviously least common multiple is different than greatest common factor. Again, you'll see the listing method we're going to go over. Same thing, you've done this before in other grades. This is good for some numbers, not for all. So numbers that we might know quickly the multiples of, good for that, not maybe for others. For method 2, using prime factorization, we're going to do that factoring again, but this time notice we want to write in an exponential form. So we want to write our product of primes with exponents. With I notice a lot of us might be struggling with, so we got to practice that. And then what we do is we're going to multiply each factor to the highest power. And again, that'll make more sense when we do it, but just some steps if you want to write them down. And again, cake method, look how nice and neat. This is simple and clean, but we have to make sure that we know the difference between greatest common factor and least common multiple. Notice greatest common factor, normally we just multiply those 2 digits. On this, we are multiplying the shared factors as well as the remainders after they've been divided. So if this is a good spot for either screenshot or write down the steps, do what's best for your learning, and let's continue. Okay, here I go. I'm going to find the least common multiple for the numbers 6 and 10. So if you're in your notebook, you should be writing down what we're doing. Make 3 columns so that you can do each as well. So method 1 was that we were going to list our multiples. So starting with 6, I know that my multiples are 6, 12, 18, 24, 30, 36, 42, and I might stop there for now. 10, my multiples were 10, 20, 30, 40, and I'm going to stop there because something rang a bell. You look for your least common multiple. So I noticed that 30 popped up here and here, and nothing popped up before that. So that is representing that my least common multiple, the smallest number that both 6 and 10 multiply 2 is 30. So pretty basic on that. Okay, so for prime factorization, we are going to look at the steps here. We're going to make a factor tree. For 6, we know our primes are 2 times 3. For 10, we know the primes that make 10 are 2 and 5. So then we're going to prime factors each with exponents. In this case, they don't have it. So 6 is 2 times 3. 10 is 2 times 5. So this is not an example with exponents, but if they did have exponents, we would want to write them in exponential form. So for example, if it were 9, we would not write 9 by 3 times 3. We would want to write it as 3 squared, just as an example. So then what we're going to do is we have to take the highest power of each factor that appears. So notice we see that 2 shows up twice, but we're only going to consider one of them. So we're going to take a 2, we see another number 3, and we see another number 5. So then what we're going to do, I guess we forgot to say that, we would need to multiply those together. So we're going to multiply 2 times 3 times 5, which is 30. So the least common multiple is 30. And I'm hoping when we get to some exponents, that'll be a little bit more clear too. So now trying our third method, our nice clean method, the cake method. So that's when we divide by common shared prime factors. 6 and 10 are both even, so I'm going to divide by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So we could tell right now, yes, this is my greatest common factor, but we're not looking for that. We're looking for our least common multiple. So in this case, we are going to take the greatest common factor, but also the remainders. So this 3 and 5. Notice I'm kind of making an L. Think L for least common multiple. So then I'm going to multiply those together. 2 times 3 times 5, and I get 30 is the least common multiple of 6 and 10. So again, you're considering that factor of 2 only once because it works for both of them. But then if we want to consider multiples, we have to consider the remaining part that isn't part of the other number. Okay, so I would love it if you were feeling willing to give these a try. You can use any method you want. You can try any of them. I would suggest you try at least each one once, but then come back and check in. So for 45 and 75, I'm thinking already about listing those, and I'm like, no, that's going to be crazy to list out those multiples. I'm not confident in counting by 45s or 75s. So for this one, because these are larger numbers, I think prime factorization is going to be my best option. So I'm going to make factor trees for both of these. For 45, I know factors are 5 times 9. 5 is prime. I'm going to factor 9, which is 3 and 3. Those are prime, so I'm done. I like to write that out, 3 times 3 times 5. For 75, I might choose 3 and 25 or 5 and 15. For 15, I'm going to choose 3 and 5. Again, circling all the way till I get to my primes. So that was 3 times 5 times 5. So remember when I told you to write them least to greatest, that makes it a little easier. To then, now we talked about writing them with exponents. So this is the same as 3 squared, because 3 times 3 times 5. And this is the same as 3 times 5 squared, because there's 2 5s. So we talked about taking each factor that shows up to the highest power. So we want to consider them. So 3 shows up, but 45 has it to the second power. So I'm going to take that one. 5 shows up twice, but this one's to the highest power. So then I'm going to take 3 to the second power times 5 to the second power. I'm going to multiply those together, which I know is 9 times 25. What I'm thinking right now is that 10 times 25 is 250, so I know that's 1 less 25 for 225. So that means that the least common multiple, the smallest number that both 45 and 75 multiply to, is 225. So then looking at 3 and 12. I'm thinking 3 and 12 are numbers I'm pretty confident in counting by, at least up through their 10th multiple. So I'm going to try listing here. So I'm going to do 3, and I say, okay, 3's multiples. 3 times 1. 3, 6, 9, 12, and I say, hold up, 12. One of my numbers is 12. So then I write, okay, well, 12, remember, a multiple of 12 is 12 because we always start with that number. That number times 1 is itself. So right away I can see, hey, their least common multiple is 12. Couldn't be less than. Your multiple could never be less than one of the numbers. Okay, because you always start with a multiple times 1. Listing will not be that easy always for all the numbers, so don't get your hopes up there, but always a great strategy when it is appropriate. For this last one, I'm going to do the cake method. So for 2, 3, and 5, I'm going to decide a common factor. What I notice is that they are all prime numbers, so therefore the only things they can be divided by are 1 and themselves. So they only share 1, so their only factors are 1. So 2 divided by 1 is 1, and so on. Remember, I'm going to make that L for least common multiple, multiply my factors together, 1 times 2 times 3 times 5, 2 times 3 times 5. If you want to show your work working down, I see that that is 30. So the least common multiple of 2, 3, and 5 is 30. And you can think, okay, well, it would be 2's 15th multiple, 3's 10th multiple, and 5 is 6th multiple. So it seems accurate. Yay, real world example. So Lucy needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12. Napkins come in packages of 16. And cups come in packages of 8. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? Some of you are thinking, what is happening? But what I think this really means is she wants to have the same number of these, but they come in different amounts. So what she wants to do is she wants to buy multiples of each package so that she can pair them together and have no leftovers. So she wants to have no leftovers. If you've ever seen Father of the Bride, you will know that George Banks loses his mind in the grocery store because hot dogs and hot dog buns do not come in the same packages, which probably, if you ask your parents, is frustrating because you always have too little or too much of something. So let's figure this out. So naturally, I think I want to do the cake method, but something you have to know is that the cake method for least common multiple does not work for 3 numbers. I did this previously and got 96 and then later was corrected. So I'm going to do my product of primes here, and you also could do listing, but I know we need more practice with the other one. So if I do 12, I think my primes are 2 and 6. Primes of 6 are 2 and 3. For 16, my primes are 2 and 8. For 8, it's 2 and 4. And for 4, it's 2 and 2. Then lastly, for 8, my primes are 2 and 4. And for 4, it's 2 and 2. So remember what you do is you list these out using your exponents. So 12 is 2 to the 2nd power times 3. 16 is 2 to the 4th power. And 8 is 2 to the 3rd power. You take the primes that show up, if they show up more than once, to the highest power. So I'm going to take this 2 to the 4th power, and 3 shows up. I multiply those, 2 to the 4th times 3, which is 16 times 3, which is 48. So that means I need 48 plates, 48 napkins, 48 cups. And then so the question asks, what's the least number of packages? So I'm going to have to do some extra math there too, and I'm going to have to divide now or figure that out. So I'm thinking, okay, well, if I need 48 plates and they come in packages with 12, I'm going to need 4 packages. If I want 48 napkins and there are 16 in each package, that means I need 3. And if I need 8 cups and they come, 48 cups and they come in packages of 8, that means I need 6 packages. So that's what that shows me. The only benefit there is if you did do the cake method for some reason, it's not going to give you that number. It's going to give you 96 accidentally, but it would give you those leftovers, I think. Maybe you could try it. And then listing, of course, also works because then you do 12, 24, 36, 48, 16, 32, 48. Then counting by 8s, 8, 16, 24, 32, 40, and 48. So we can see that they all have a multiple of 48. Okay, so here's your opportunity for you to do. If you have your template, put them on there. If you are in your notebook, go ahead and copy them down. This is your opportunity to try. Many of you have been skipping this. Don't. Make sure that you are trying and challenging yourself. It's okay to get them wrong, then we can review them and go over them. If you don't try, then you don't know what you know. Make sure you pay attention. The first two, you're looking for the least common multiple. You can use any method you'd choose, but please show your thinking. For question 3, you are going to review. So sometimes we get all discombobulated with the least common multiple and greatest common factor because there's a lot of similarities. So I want you to review, then switching back and going to greatest common factor on that last one. Can't wait to see your work. So make sure when you're done, you look over your notes. Do they make sense? Do I have everything I need? Explain something to a friend or family member. Rewatch any sections you need, or check out Miss Little and Miss Grinder's videos. Trying more practice problems on iExcel is great too. This time, you can put them on iClassic if you want, but we'll be checking them in class or on Zoom. Have a great day.